Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Kubernetes has 92% of the container orchestration market. Docker Swarm is coming back from the dead. Both of those statements are true in 2025, and they tell you everything about where we are with container platforms.
That's the paradox right there. Kubernetes utterly dominates. 5.6 million developers, 60% enterprise adoption, heading toward 90% by 2027. And yet, the loudest conversation in platform engineering right now is, do we actually need this?
Because winning the market doesn't mean it's the right choice for every team. I've seen companies rip out Kubernetes after 18 months because they finally did the math. 3 full-time engineers maintaining the platform, tools sprawling everywhere, and they were running 30 services that could have lived happily on ECS.
Let's talk about that math, because 88% of Kubernetes users cite rising costs as a major challenge. 42% say it's their number one pain point. That's not a niche problem. That's the majority of teams struggling.
Right, and it's not just money, it's complexity. The CNCF landscape has 209 projects now. That's not an ecosystem, that's analysis paralysis as a service.
Okay, but let's be fair. Those 5.6 million developers aren't all making bad decisions. Kubernetes is solving real problems at scale. The question is, what scale?
That's what I want to dig into. When does Kubernetes make sense in 2025? When are you better off with something simpler? And what's actually changed in the ecosystem that senior engineers need to know about?
Let's start with the ecosystem changes, because there's some legitimately interesting stuff happening. The service mesh space just went through a revolution.
Istio 1.24 hit general availability with ambient mode, service mesh without sidecars.
Which is huge, because sidecars were the thing everyone complained about. Resource overhead, debugging complexity, that weird proxy injection magic that broke when you looked at it wrong.
Ambient mode uses a node-level proxy called ztunnel. Red Hat's doing the same thing in OpenShift Service Mesh 3. And honestly, this makes Service Mesh way more palatable.
The market thinks so too. Service Mesh is at $2.5 billion in 2025, projected to hit $15 billion by 2033. That's a 35% compound annual growth rate.
But here's where I push back. 31% of Kubernetes users have adopted Service Mesh. That means 69% haven't. And for a lot of those teams, that's the right call.
Because if you have fewer than 100 services, you probably don't need the complexity. Just like if you have fewer than 200 nodes, you might not need Kubernetes itself.
Exactly. And there's an alternative path that's even more interesting, Cilium with eBPF. It bypasses the traditional service mesh model entirely by working at the kernel level.
Which brings us to the other major ecosystem shift, AI and machine learning integration. Kubeflow used to be this niche thing that only a few companies touched. In 2025, it's basically mainstream.
Kubernetes became the default platform for production AI workloads, training jobs, inference pipelines, managing GPU-heavy workloads. And it makes sense. You need orchestration at that scale.
But AI workloads are stressing Kubernetes in new ways. They're stateful, resource-intensive, and they don't play nice with the standard pod lifecycle. Platform teams are having to add AI-specific abstractions.
And then there's the shadow AI problem. 85% of engineers are using unauthorized AI tools. So now your Kubernetes platform needs AI governance built in. Multi-model support, cost attribution, compliance guardrails.
Which ties into another trend, edge computing and serverless Kubernetes actually working in production, K3s and micro K8s dominating edge deployments.
The edge story is interesting because it flips the operational model. Instead of managing a few large clusters, you're managing hundreds of small clusters distributed everywhere. IoT devices, 5G infrastructure, localized data processing.
And on the serverless side, EKS Fargate, GKE Autopilot, AKS virtual nodes, they're removing cluster management entirely, which raises a philosophical question. If you don't manage the cluster, is it still Kubernetes?
From a user perspective, maybe not. And that might be where this whole thing is heading. Kubernetes becomes invisible infrastructure. You benefit from it without knowing it's there.
Let's talk about what's changed in the platform itself. Kubernetes 1.31 and 1.32 had some significant updates.
1.31 completely completed the removal of all in-tree cloud provider integrations. That's a big deal for vendor neutrality. It took years to finish that migration, but now Kubernetes is truly multi-cloud ready.
1.32 graduated the memory manager to general availability, better resource allocation for containerized applications, especially important for those AI workloads we talked about.
And stateful set persistent volume claim auto cleanup. Small feature, but it's emblematic of Kubernetes maturing. They're focusing on operational simplification now, not just adding features.
Security hardening too. Anonymous authentication is now restricted to health check endpoints only. Everything else gets a 401 unauthorized response.
The stability story is improving. Breaking changes are slowing down, which is a maturity indicator. But the upgrade burden is still real. 3 releases per year, tight support windows. That's operational overhead you have to budget for.
Which brings us to the alternatives that are gaining ground. Docker Swarm legitimately came back from the dead.
I did not have Docker Swarm revival on my 2025 bingo card, but here we are.
Community-led resurrection, and people are using it because it's simple. 10-minute setup versus a 2-week Kubernetes learning curve. For teams with fewer than 200 nodes and fewer than 50 services, that simplicity wins.
HashiCorp Nomad is in the same boat. Multi-workload support, containers, VMs, batch jobs, with way less complexity than Kubernetes. When you don't need the full orchestration power, why pay the complexity tax?
And then the cloud-native services are winning development environments. AWS ECS with Fargate, Google Cloud Run, Azure Container Instances.
The developer experience argument is compelling. Developers want to ship code, not learn kubectl. If you can containerize your app and push it to Cloud Run, you're in production in 15 minutes.
The PaaS renaissance is part of this too. Fly.io, Railway, Render, Heroku-like simplicity with modern underlying technology.
Let's talk about the cost equation there because it's eye-opening. $400 a month for a PaaS versus $150,000 a year for a platform team. For a startup with fewer than 100 concurrent users, that math is pretty clear.
But once you hit scale, it flips, which is why we're seeing hybrid strategies. Kubernetes for production, simpler tools for development and staging.
Kubernetes for what matters, simplicity for everything else. I've seen companies run customer-facing services on Kubernetes and internal tools on ECS. Makes total sense.
So let's give people a decision framework. When should you use Kubernetes in 2025?
Use Kubernetes when you have 200-plus nodes, complex orchestration needs that simpler tools can't handle, multi-cloud or hybrid cloud requirements, and a mature platform team. At least 3 dedicated engineers, realistically more like 5 to 15.
And skip Kubernetes when you have fewer than 200 nodes, monolithic applications, limited team expertise, or you need fast time to value in under 3 months.
Now let's talk skills, because the job market tells you what actually matters. Core Kubernetes concepts are table stakes. Pods, deployments, services, config maps and secrets, kubectl fluency.
And when I say fluency, I mean actual debugging, not just copy-pasting from Stack Overflow. You need to understand what's happening when things break. RBAC and security fundamentals, persistent storage, PVCs, PVs, storage classes, and Helm is non-negotiable. 75% adoption, up from 56% in 2023. If you're doing Kubernetes, you're using Helm.
The rising skills are in platform engineering. 60% of enterprises are forming dedicated platform teams, and they need people who can build golden paths and self-service abstractions.
That's the hot area right now, making Kubernetes invisible to developers by building internal developer platforms on top. If you can design for developer experience, you're commanding premium salaries.
Security and compliance are rising too. Service mesh for zero trust, policy as code with OPA or Gatekeeper, supply chain security with SBOMs and admission controllers, FinOps integration for cost attribution.
And AI and ML workload management, GPU scheduling and quotas, multi-tenancy for data science teams, MLOps toolchains on Kubernetes. These are new skill areas that didn't exist 3 years ago.
What's declining in value?
Manual kubectl operations are becoming commoditized. Automation is expected. And specific tool certifications, CKA is still valuable, but it's not sufficient anymore.
Deep knowledge of specific vendors is also declining. Multi-cloud abstractions are winning, so being an AWS Kubernetes expert versus a GCP Kubernetes expert matters less.
Let's talk about what actually gets tested in interviews, because I've been on both sides of the table recently.
System design with Kubernetes. How would you build a multi-tenant platform? That's the question that separates mid-level from senior engineers.
Incident war stories, troubleshooting production issues. They want to hear about the time everything caught fire and how you fixed it.
Cost optimization. Why is our AWS bill $50,000 a month for Kubernetes? If you can't answer that, you're not ready for a senior platform role.
And trade-off thinking. When would you not use Kubernetes? If your answer is always use Kubernetes, you've failed the interview.
Salary context. Kubernetes skills alone are pulling $144,000 to $202,000 in North America. Add platform engineering expertise, and you're in the senior to staff tier.
Specialization matters. Service mesh, AI and ML, security. Those command higher rates because fewer people have deep expertise.
All right, practical wisdom time. What are the biggest mistakes teams make with Kubernetes in 2025?
Mistake number 1. We need Kubernetes because everyone else uses it. The cargo cult problem. 88% struggle with costs. 42% say it's their top pain. Don't adopt complexity without understanding why.
Mistake number 2, underestimating total cost. Direct costs are compute, storage, networking. Hidden costs are the platform team, 3 to 15 FTEs typically, plus training, plus tool sprawl.
Most teams underestimate by 3 to 5 times. They budget for servers and forget about the humans.
Mistake number 3, tool proliferation without strategy. 209 CNCF projects create analysis paralysis. The best-of-breed trap leads to 15 tools with 15 different UIs.
Start minimal. Core Kubernetes plus Helm plus basic observability. Add complexity only when pain is proven, not anticipated.
Mistake number 4, ignoring developer experience. Platform adoption fails when developers hate the tooling. If developers are still SSHing into nodes, your platform failed.
Measure deployment frequency, time to first commit, developer satisfaction. Those metrics tell you if your platform is working.
Mistake number 5, not planning for day 2 operations. Getting Kubernetes running takes 2 weeks with tutorials. Operating Kubernetes at scale takes 3 to 15 FTE ongoing.
Upgrades, security patches, breaking changes, add-on management. Who's on call for the platform? If you don't have an answer, you're not ready.
Here's the decision framework I use. Start with scale. What are your actual numbers for nodes, services, team size, traffic?
Ask about expertise. Do you have Kubernetes skilled engineers? If the answer is we'll learn, be honest about the timeline. It's a 6-month ramp-up minimum.
Calculate total cost, including human time. Consider timeline. If you need production in 3 months, Kubernetes probably isn't the answer. And evaluate what you're optimizing for. Control versus speed versus cost versus simplicity.
So here's the key insight for 2025. Kubernetes isn't a question of should we use it, it's when does it make sense.
For large-scale, complex orchestration needs with teams that can support it, Kubernetes is unmatched. For everything else, simpler alternatives often win.
If you're evaluating Kubernetes today, calculate your actual scale, assess your team's expertise honestly, consider alternatives first and rule them out deliberately, start minimal if you do choose Kubernetes, and prioritize developer experience because platform adoption is your success metric.
The future signal I'm watching is serverless Kubernetes. As cloud providers abstract away cluster management, we might see Kubernetes becoming invisible infrastructure. You benefit from it without knowing it's there.
That might be the ultimate maturity, when the technology disappears and you just focus on deploying applications.
Kubernetes won the orchestration war, but winning doesn't mean it's the right choice for every battle. In 2025, the sophisticated move is knowing when to use the sophisticated tool and when simpler wins.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.